So hello, I'm Paul, and I worked for Linaro for a while, and I'm also a Debian developer for a while. So today I'm going to talk about the SystemReady certificate, especially for the IR class. So SystemReady is basically a certification program made by ARM. And nowadays, if you see the market, there's already some boards already have this certificate passed. So if you look into the graph, there's 4 large categories. But before I go into the detail of these categories, so let's think about the ARM environment. Right? So many of us, I mean, have you heard that there's some roles like the embedded engineer or IoT engineer? So what's the difference? Why is so special for ARM has this kind of roles in those companies? So yeah, because I mean, previously ARM systems are very complex, so you need some experience of that. But things are changed. So think about x86, okay? Because we are all familiar with x86. So like you and me, or younger me, we are very, very familiar with x86 platform because our laptops are x86, our desktop are x86. Almost everyone writes programs on x86. So think about a scenario. So your friend, or your family, or your customer would like you to write a program to solve his problem. So what will you do? So you write a program in your computer, x86, and after you're done, and you deploy the program to him. And if he's using Debian or Ubuntu, then you ship the source code to him, and he recompile it, and it mostly will run. And if he's using Fedora or Red Hat, you can package it as RPM, or you can use like Snap or Flatpak, those cross-platform packages, and deploy your program to him. But it's also like if maybe he's using Windows, then you can consider Java or maybe MinGW, compile ESC, and use NuoSoft installer to make something for him. But did you notice that? You are only worried about the operating systems. Some problem you won't worry about is, for example, my laptop are made by HP, and his laptop is made by Dell. Or maybe my program doesn't work for you because you are using Dell laptop and might be using HP laptop. Or something like, my CPU is Intel CPU, and your CPU is AMD CPU. And maybe my program doesn't work for you because CPU vendors are different. So this problem you usually not worry about when you are using x86 platform. But ARM is different because ARM, there's a lot of SoC vendors because ARM sells the IP to the SoC vendors. And SoC vendors will make different chips and have different ways to run it. So normally if you are using ARM, then you buy a board, and the vendor or the customer will ask you that, we want to use this board, and you have to buy that board, and you download the BSP or you get the BSP from that board vendors. And sometimes you are not able to use Debian because the board vendors give you something else. It might be a distro, but it might not be a distro. Like they give you some images made by Buildroot, or it gives you some image made by Yocto open embedded. So based on this, if you get an image not Debian, then you have to write the program. Think about it. Write a program, and you have to make your program run on that image. And maybe your program depends on some library which is not in that image, and you need to port that library to that image too. But maybe you can think another way, because we can try to install Debian on those platforms. Like we have debootstrap, we have live build. You can build an image for the hardware you want. But that's also very complicated. So what the board has a system-ready certificate means. So it means, also, I didn't finish. So why is it so hard? And think about it, the hardware itself, okay? And some board using SD card as their storage. Some board using eMMC or NAND and NOR flash just to store the boot firmware. And think about it, SD card is the much simpler stuff. You pull it up, and you put it on your computer, and you flash things, and you put it back. But for eMMC, it's soldered on the board. For NOR and NAND flash, it's soldered on the board. So you have different ways to flash it. Maybe you can DD it, something implement the OTG. So when you connect it to the computer, you can DD to the device. But some don't. Some using a proprietary protocol, and they provide a Windows tool for you. So you have to use Windows to write the image to the board. So boards with system-ready certificate is actually require this to be implemented. The first is the UEFI boot. So that means it's similar to the x86. So you have they unify the boot process. So UEFI, you put into grub, because grub can be compiled as a UEFI application. And also, the installation process is also unified. You can use the UEFI, set the boot orders, like you said, USB is my first boot device and eMMC is the second. So you can use the USB device for installation. And also, a system-ready certified board must support the UEFI capture update. So that means it unifies the ways to write the boot firmware itself, like the U-boot. So you don't need to care about where U-boot puts. It might be put in the SD card, or it might be put into the NAND flash or NOR flash, but don't care about it. You have a unified way to capture update it. So remember, we have 4 different classes of the certificate. Well, I'm focusing on the SystemReady IR. So I don't know much detail in the ES. But what I know is for SystemReady IR and SystemReady ES, to the users or to the application developers, there's nothing different. But if you look into the detail, the IR, we can use device tree. But for ES, it is required to use the ACPI for the device drivers. Okay, I need to be quick. And SystemReady IR, just as I said, supports the UEFI boot and UEFI capture updates. And the device tree is provided by the boot firmware. So if you know that device tree was originally provided with a kernel, but now we need to give the device tree directly from the boot firmware. And there's also another certificate called SID certificate, which with this certificate, you have the UEFI secure boot stuff. You can set the PK, KKDB stuff, just like x86. So yeah, since I don't have time, let's demo it, because live demo is much better than words. So I bring this board. It's made by an Israel company called the CompuLab. And it's an industrial computer, and it's ARM-based. So let's open my serial console. And this is a Debian image I just downloaded from the official Debian website. It's a mini.iso for ARM64. And I plug the USB here. Okay. And I power it up. And you can see. Wait for a while. And you can see, I directly go into the Debian installer. It's just like x86. So if you click the install, and wait for a while, you will go to the Debian installer. Yeah. So this is a Debian installer. Yeah, I don't have Ethernet here. But if I have Ethernet here, then I can, go further. But I can only demo like this. But let me show you another thing. Is I already installed Debian before I come here. So let's boot it again. And you will see it boot into Grub, and will boot into Debian. Yeah, wait for a while. Yes, so this is the Debian, and you can choose the kernel versions from the Grub menu. And it's yes, okay. So any questions? Okay, if you don't have questions, I'll continue with this slides. And for the boards, for the board vendors who want to implement the SystemReady IR, I could suggest that rebase your BSP to latest U-boot method branch, because we upstream some features in latest U-boot branch. So better to rebase on that. And also, please check your TFA and UPT to the latest versions. Of course, I know, to pass the certification, you have to run this test. This tool is provided by ARM. If you have questions or something in details, I know there's always in details. If you really need help, Linaro can help you. Yeah, thank you.